Man, 11:07, y'all. We are almost done. Can I delete? Wait, what class is this?
I was just going to ask the same. What is that?
That's my in-person class. I deleted all the assignments because we do them all in class. And they don't even turn them in because I walk around and watch them all. Okay, so we're doing 9-1, number 3, and we're going to talk about this project again. Did you all have time to do the ones for you, Cindy, the 9-1?
We did not, and that will be the 9.1 worksheet number 2.
Perfect. I think we might even need, that might not be, well, we'll see how it goes. This might not be enough to fill the full class time.
Yeah, they might be able to do part of 1 as well.
Okay, so let's just real quick remind ourselves about this project part. All that we're asking you to do right now for this project is to get the M&Ms and Skittles bags. So there's just the 2 bags, and then you can take a picture and add it here if you want. Remember, you want to download this as a Microsoft Word document so that you can edit the things. What I'm most interested in are these numbers, and then we're going to use them for the rest of the chapters. So you can upload it here so that it's not lost, and then you can download it again later, or just keep this present with you. And then the later projects, you may want to print them. In fact, I kind of encourage you to. You don't have to. You can type them. It's just a little annoying typing mu x bar, which you're not going to type, but like mu p hat or these other little things. So it is easier to handwrite these. There is a file provided for you. If you want to do it all electronically, you're welcome to. It's here. You'll want to download this, and then you can copy and paste the symbols from here into your own Word document if need be. Like, here's all these formulas for confidence intervals and sample size. And if I recall, some people had problems copying it from here. Yeah, so it doesn't quite copy from the Google document. Let me see what happens if I download and copy. So that's what's coming. Any questions, you all that are here on that? Let's see if I can make this happen again. Yes, now it's going to work. Yep, okay. Do not save that. Okay, well then, without questions, let's just dive in then. So what we're doing today is we're going to start with the 033 worksheet. Why am I putting a decimal? I don't know. And this is what's due on Sunday. I think you should, as I've been saying all along, no, we don't want the midterm, is you should open the reference sheet that you're going to use. Just like for chapter 8, this entire chapter 9 is all on the provided reference sheet. There's very little that you actually need to type or write on your own personal reference sheet. So we're talking about page 272. And there are confidence intervals for single population proportions, which that symbol is P. And remember, the sample proportion is P hat. If you've forgotten it, the formula for that is X over N. And remember, X is the thing of interest. Really, we define that as success. And N is the sample size. So the number of objects in the sample. Okay, so this is the thing to keep track of. Now, I know you talked about this in your, when you went through the notes, when we talk about, computing the margin of error. So here's this margin of error formula. It's the critical value times the standard deviation of the p-hats. That's one way to calculate it. The other way, well, I guess that's the way we want to do it here. So who needs to remember how to calculate this? And who remembers what this is?
I would love a refresher.
Okay, let's do it. The good news is the refresher is right here, critical Z values. We're finding the Z value that traps the area in between the confidence level, not alpha. So I know you talked about this in your notes. Alpha is equal to 1 minus the confidence level. You do need to know that, because there are times where I'm going to say, hey, what's the confidence level or what's alpha? But we used to use alpha to do this calculation, but now we use the C level because we get both numbers just automatically. So let's look at our problem here. We've got a confidence level of 88. So that means the first thing you need to remember to do is that the C level is 0.88. So to calculate the critical Z values, we just need to get to StatCrunch. Oops, that's not what I wanted to do. Come on now. And anyone remember what Z stands for? What's special about Z?
Is that the one that it's the same on both sides, but it's the opposite? So like one side's negative, one side's positive?
Good. Let me be more specific. That's 100% correct. That's important to remember. Yes. Which is why we can use this plus or minus thing right here. That's what that's saying. What's the mean and the standard deviation when we're working with Z-scores? That's the other thing we need.
Is the Z-score the 2 deviations away?
We definitely, yes, you're nailing that. We use that to check for unusual. So if you're above 2 or below -2, that's an unusual value. If our data value is a Z-score, which is another good point. That's what this is. It's a Z-score, and that's the data value minus the mean divided by the standard deviation. If we're using the population.
Okay.
But if we're going to do a calculation over here in the normal calculator, we have to know what the mean and the standard deviation are. Remember back in chapter 8, that was the shape and the center and the spread. So like back here, we said, if we know that the conditions are met, we know that mu of p hat is equal to the population thing, and we know that the spread is let's see, the standard deviation of the p hats, which is what, the square root of p times q divided by n. Remember all this, which is approximately equal to something, and then we smash that in right here for mean and standard deviation, right? So what do we need to put in for the mean and the standard deviation down here with the Z-scores? What goes here and here? And since you all are typically a shy bunch in the morning, I'm going to give you a hint. What does this say?
We just keep it the same that it already is. Okay.
That's it. Z-scores have a mean, or the standard normal distribution has a mean of 0 and a standard deviation of 1. So when you open the calculator, it's going to default to the correct mean and standard deviation, but also it's right here. We wrote 0 and 1 in here for a reason, because it's always that. So if you think you're going to forget that, write yourself a little note. When you get into 9.2, it's going to be a little bit different. It's a slightly different calculator. Nothing super big to fret about. Okay, so we do the between, and what it says here is we put the sea level in for the area, which ours is 0.88. Here it is, plus or minus 1.5548. So we now know that our Z critical values is this. Doesn't give us a decimal place. We typically do 3 on these, right?
Correct.
Okay, let's go with 3 then. 1.555. Okay, anyone know then how to compute the margin of error given this information we have? Just for fun, I'm going to click over here and just like open this up. And let me just say it, because maybe you haven't done it yet. The margin of error is the critical Z value times the standard error. That's what SE stands for. Do we have those two numbers? Talk to me, Reagan.
I have in my notes upper limit minus lower limit divided by 2.
Love it. Do we have an upper and lower limit here? Because you're totally right. If we knew the upper and lower limits, we could do it, but we don't have that information.
Because the confidence interval isn't given.
Correct. Nailed
Okay.
it. Down here, we're going to do this question a little later. Here is an upper and lower limit, so we can do what you said. That's a useful thing. Good. So what we need is to understand how to compute the margin of error without knowing the confidence interval. And this is the formula. It's the critical value, the positive one, times the standard error. So let me ask again, do we know the standard error and the critical value?
Yes.
Yeah, right. We just calculated the critical value using this sea level. We were given the standard error. So the margin of error is, ooh, easy there. The critical value, we'll use the positive version, times the standard error. That's it. That's the margin of error. Now, remember what that is. That's, if we look at the confidence interval, there's this upper limit, there's this lower limit, and then there's the point estimate right smack dab in the middle. And the margin of error is the distance between the point estimate and the upper limit, so we'll call that ME, or the distance between the lower limit and the point estimate, because the point estimate is the exact center.
What
Okay.
is the point 1.555 called?
That's the critical, let me get it right.
Level?
Critical Z value
Okay.
that's associated with the alpha and the confidence level.
Eric, when they have to do the shading of the graph, you don't care that they actually have to label the alpha over 2 values, do you?
No, maybe in chapter 10.
Okay.
The
I
one
didn't
that-
know whether you want, I mean, obviously that would require a little bit more work, like what we
Right.
really don't have to do
Good thought.
because we're using StatCrunch. Like
Right.
calculator wise, we had to find those alpha over 2s, but now we don't really need to. I didn't know if you wanted them to
No,
mark
that's
those.
fine.
Okay,
Because then you could go here and, oh, there it is.
right, right, exactly.
Yeah, I wouldn't be too worried about that. Good. Okay, you all see if you can't do B and C. You got to do a calculation in StatCrunch. Here, I guess we could finish this one together. 10.4185. And again, it didn't say what to round to, so whatever. So you do B and C. Just as a recap of what you need to do, you got to find the critical Z value in StatCrunch, and then do your multiplication. All right. We'll do 5 minutes, see where you're at. And hopefully you all can do these while you're here. Because if you can't work on these while you're here, I don't know how useful this time is for you. All right. Set a timer for 3 minutes.
So Brianna, you want to go to your normal calculator in StatCrunch. So Stat Calc Normal. And then you'll leave it as a mean of 0 and a standard deviation of 1. And you'll hit the between button. And what Eric did to get the 1.555 is when you hit the between button, you're going to put in your confidence level. So he put to the area 0.88 over to the right hand side of the equal sign. And then you'll be given a positive and negative of the same value inside parentheses. So for letter B, you're going to go to your Stat Calc Normal, hit between. And again, it's a z-score, so we need to have a mean of 0 and a standard deviation of 1. And you should be putting on the right-hand side of the equal sign your confidence level. So that percent changed to a decimal. So 0.90. And then you will get your critical z value. You're welcome.
Okay, so Brianna, you got them all? Shall we check them? Let's see, 0.9. Oh, 1.645. So what y'all had? And then 0.99. 2.576. So technically what we're supposed to write here, let's see, is plus or minus, plus or minus, plus or minus, plus or minus. And then the subscripts on these is the alpha. So alpha is equal to 1 minus 0.88. And then we have to divide that by 2, which is 0.12. Divided by 2 is 0.06. So technically there's a subscript on this of 0.06. And then on this one, it's 0.05, and on this one, it's 0.005. And you may remember things looking like this without the plus or minuses back in chapter 7. That's when we first encountered those. Okay, so you'll have different answers for the one.
I got 1.6449 for B and 2.5758. I don't know.
So
don't-
for B, you and I have the same answer. I just rounded it to 3 decimal places. 1.6.
Oh, duh. Okay.
You're good.
Is that what we're supposed to do?
It doesn't particularly matter because it doesn't say. StatCrunch will say,
Okay.
and then you'll have to round to whatever they say to do. Same thing here, 2.5758. Is that what you have?
Okay. Got it. Yeah.
Good.
That makes
Now, once you have that right, did you all get the margin of errors?
Yeah,
then
did
just-
do we have to do the subscript on Z?
You are going to be asked questions about alpha. So at some point, yes, you need to understand what that is and how that functions. Right now, you didn't need to write those.
Okay.
You just need to find the critical value, and then do this multiplication. So I'm just giving you that reminder from what you saw in the notes, and then I think there's a couple questions in the worksheet we're about to, the worksheet from my class about alpha. Okay, so 16.779 for that one, and then 56.4 times 2.576 for this one, 145.286. Awesome. Okay. Any questions on that? Anyone lost?
So is it okay since I rounded differently that I got like teeny
Mhm.
tiny different? Okay, just in the exam, it'll tell me how many decimals. Got it.
And if I'm grading and you write how I wrote this, I know what you did. So I wouldn't have to mark you wrong. Just as a reminder, we found the critical values using this information on page 271. And we then calculated the margin of error using this information on page 272, which of course is just a summary of what you saw in the notes yesterday. Okay, so the second one, I'm going to let you all attempt this. Thinking about, this is getting you to think about, what does the sea level really mean? So let me give you 3 minutes. You read this. If you get stuck, call us. Set a timer for 3 minutes.
You guys may want to look at Eric's picture because it's in color. It's a little bit easier to tell, like letter A.
Okay, what are you all thinking here? How many polls didn't have 0.45 in the confidence interval? Do you all know how to read these intervals, by the way? Maybe we should have checked
So
on.
you guys, if you're stuck, look at the notes on page. We did one exactly like this on page 209.
A lot. Okay. Count them. How many?
5.
So nice. 1, 2, 3, 4, 5. There's 5 confidence intervals. Very good. That don't have this line in them. So this is a weird graph. This is the x-axis. And then this is the y-axis is the number of, is like each individual poll. So here's 1, here's 2, or each confidence interval. So this 0.45 is the true proportion. Somehow we knew this. I don't know how we knew this. Which is really what we're guessing at. So then we're noting that 5 of these do not have 0.45 somewhere within the lower limit. So this little thing here would be the lower limit and the upper limit. So this confidence interval contains the true population proportion. The point estimate, in other words, the p hat, are the dots. And there's a couple like this particular sample has the p hat exactly what the population value is. A bunch of these others don't. And then these ones in red are the ones that don't have the 0.45 within them. Although if we look really close, I don't know, this one kind of looks like, ooh, eyes destroyed. This one looks like it's in there. Okay, let's just, oh boy. How are your eyes this morning? There we go. Okay, so we got 5. So then what's the confidence level? And I think we should go to this page. The formal interpretation of confidence level says, if you take many samples and make a confidence level from each one, then 1 minus alpha times 100% of the confidence intervals will contain the true value of the population parameter. So if 5 out of the 100 confidence intervals don't contain 0.45, how many do contain 0.45?
95.
Nailed it. And that's the confidence level. 95%. So this is the theory that we use when we pick a confidence level. It says, hey, we know that if we were to continually sample from this population, 95% of them would have the correct parameter, which is the thing we're trying to guess. Talk to me, Reagan, what you got?
So what, the 5 is just a 5 and then the confidence level is the percent?
Yeah, so this said how many of the polls did not contain. So it's asking how many polls,
Okay.
which is just 5. What this number is related to is that alpha is equal to 5%. So the alpha is the percent of, like, it's kind of like percent error. It's the percentage of the polls that we expect to not contain the correct parameter. So their point estimate, they don't have the true value of the population, which is the thing we're trying to guess. Well, not guess, but the thing we're inferring from the reference sheet or from the sample. Okay, so now we have a nice little just statement of the confidence interval and a quick reminder. I know you saw this. I put it up above, and you saw it in the notes. A confidence interval is constructed from a point estimate, which when we're talking about proportions, that point estimate is p hat, that's the middle. Then we have that's not right. We have from this a margin of error, which we add and subtract from the point estimate to get the upper and lower limits. Right, so the lower limit is the point estimate minus the margin of error. The upper limit is the point estimate plus the margin of error. So we could write it like this: point estimate minus margin of error equals this number. Point estimate plus the margin of error equals this number. So some of the questions you're going to be asked to think about is, we're going to give you some margins of errors, and you are to write out the confidence interval. We often write the confidence interval in this form: lower limit, upper limit. And when it's a proportion, we tend to write it in decimal notation as opposed to percentage notation. So I want to see if you can answer 3 and 4. Let's say I want you to get down to part B here, because they're all kind of related. This we already did. This, you have to think about what I just told you in terms of what the point estimate is. Ooh, it's the p hat. And then this one, you're just supposed to write out the confidence interval because we've given you some of this information. The key is figuring out what is what. So I'm going to give you 5 minutes to get these 3 questions. If you get those 3, keep going. Do all of question 4 if you can. Set a timer for 5 minutes. Okay, that was 5 minutes. Anyone have an answer for number 3?
.14.
What is the 0.14?
Well, I was doing what we did with the confidence level over there, but now I'm seeing that that's not the same thing.
Right, so when we say state the confidence interval, it means your answer is going to be like this, and you're going to have 2 numbers, one for the lower limit, one for the upper limit. So,
She's actually done answer 4A.
oh,
Oh, no, never mind. Never mind.
I mean, that's what the answer for 4A would look like, yes.
It would have been. Sorry, I didn't even realize
No
this.
worries.
Yeah, so you've given the point estimate.
That's it. This is a p hat, which is needed, right? Which is the point estimate. Meaning, so hopefully you all are catching what this is. We go out, we grab a sample, and from the sample, we ask and this one, we're like, hey, are you going to delay getting married due to debt? And 14% of them said, yep, we don't want to get married because we have too much debt. Our goal is to figure out what percentage of all millennials will delay getting married due to debt. So this is our estimate. We think it's 14%. And then we have a margin of error that says, well, we have a confidence level of this. Let's pretend it's 95. It doesn't say here. So we're like, well, we're 95% confident that all millennials will be within these bounds. So Brianna, how did you get that particular number, 0.176? Or another thing we could do here that might be helpful is we could draw the number line. We've identified the point estimate, which is the middle, 0.14. What is this thing? What's that 2.5 percentage points? And where does it go in the picture? Because the goal, by the way, is to find this number and this number. We need
Is that
2
the
numbers.
margin of error?
That is the margin of error. Why? Because it says so, right?
Right.
Well, isn't
Nice.
that where it's 3% plus or minus?
That's the idea, except the middle one is the 14%, and the plus or minus is, we got to change it to a decimal, 0.025 here and 0.025 here. That's the distance between the lower limit and the upper limit. Or based on the little like formula I gave you up here, we're going to add 0.25 to 0.14, sorry, 0.025, and we're going to get 0.165. That's the upper limit. Talk to me, Reagan.
So the margin of error is what you add or subtract every time to the middle thing. Okay, that makes. I
That's
thought it
it.
was always 3 for some reason.
3 is what
Nope.
we did in the notes.
Right,
there
and I
as
just
the
thought it was always
example.
3. Okay, that makes more sense.
That
It's
was
all-
our margin of error. And so you
It's-
guys are looking at page 207. That was the margin of error at that time, but that's not always a margin of error.
And that margin of error, oh boy, okay, 207. This margin of error, let's see, you got it from here, and it said plus or minus. That's nice. It didn't, so this one, it didn't say margin of error is this. It was just you understood that whatever you add or subtract is the margin of error. So yeah, so in this case, it says, hey, this is the margin error. You need to recognize it means plus or minus that, added to the point estimate.
Would it be okay just to leave that as a percentage and
Yeah.
say 16.5 and then
Oh.
subtract 2.5?
Well, so you could write, so this is a correct answer to write it like this. It's not, I don't think it's commonly written like that in StatCrunch.
No, what I'm saying, is it okay to leave them as percentages?
Oh, yes, that's okay too. So 16.5%. And then subtract it, what's that, 11.5? No, 12.5? No, 11.5.
11.5.
Yes, that's okay too. I don't know how StatCrunch is going to demand it. I don't
Hard
know.
telling.
Yes, they might do both. So either one of these two results is correct. Even this is technically correct. This is how my, in some of my grad school classes, this is how we tended to write it. But we also wrote it like this sometimes. It just, depended on what you felt like at that moment. So what this is saying is the true proportion of millennials that are going to delay marriage due to debt is somewhere within these bounds. It could be as low as 11.5%. It could be high as 16.5%. Like, you should, if you've been paying attention to the upcoming election, which is what voting is tomorrow, right? You'll see polls. I haven't been watching the news. I can't handle that stuff right now. I got enough of my own life to worry about. So I'm just like, I'm going to go vote and not worry about all the predictions. But any good news organization is going to state, hey, this person is polling at this percent from our sample. And then they state the margin of error as a plus or minus. They should. And if they overlap, meaning if the two candidates have overlapping potentials, like their p hats are different. So let's say, like, you know what, let's not even talk about it. If they overlap, then they're equally likely to be elected. We don't know. We have no clue who's going to get more than 50%. So you got to pay close attention to the margins of error. That's where the true value is at a particular confidence level. And remember, what we do as statisticians, the practicing people out there that do this for a living, they take one sample. They don't take 100 samples. They take one, and there's a 5% chance that the one sample they got doesn't actually reflect the population. So like if this was the one they got, they're below the actual reality. So whatever their prediction is totally not correct, or here it's above. So they could be saying someone's going to win or someone's going to lose based on this polling. They're just 95% confident. Okay, so did you all get the point estimate for 4A? Let me ask you this. What is a point estimate?
My notes say sample statistic, which is the center of the interval, which is like p hat and the mu of z or something.
It's
So
either
what's
p hat or x bar.
So what's the
X-bar.
formula, how to find p hat?
I'll give you a hint.
Yeah,
It's on page
This-
260 something. Go ahead. What is it?
I don't know.
Here's your hint.
Good, Nicole.
Nice. X over N. Okay, so first we should step back because remember how in the chapter 8 review, the only thing we did together was write out, is this a proportion or is this a mean? So in number 4, are we working with a proportion or a mean? And how do we know?
It doesn't say mean.
Yeah, it doesn't say mean. Does it say proportion?
It would be a proportion,
How do we
right?
know?
Because of the percentage.
Yeah.
Oh, so that's scary because this percent confidence interval is going to be the same when we're working with a mean. But you're right to look for a percentage, because if the statistic, if the sample value is a percent, then we're working with a proportion. But you're going to find that every single problem we do from here on out is going to have this confidence interval percent with it. So this
Since
tells
it
us
has-
something.
Since it has like the 203 out of 344, that's how we find out.
There you
So
go.
it's
That's it.
the 203 is the proportion of the people that we're talking about. Is that more of how I should look at it then?
Well, the 203 is the X, not the proportion. And the 344 is the N, which is the
And
sample
we're
size.
finding the
And-
proportion.
Yes, and we can make the p hat, the sample proportion, from that. So this is the most tricky of them all, in my opinion. Means often say average or sample mean, and there's a standard deviation. Those are a little easier to tell. So whoever said that it doesn't say mean, that's a good indication that this is probably a proportion. And then Reagan, I know it was you, when it says something out of something else, that's definitely a percent. Good. Yes, it also doesn't say all, but that's kind of on purpose, because what's going to happen now is we don't know the all. We don't know the proportion. We're going to look for the sample. You're always going to be given sample information from here on out. Chapter 8, remember, was the theory for why we can use a sample to predict a population value. So we gave you the population values and said, pretend we know this. What do we then know about this sampling distribution of a statistic? Now we're going to say, let's go backwards. We collected a sample. We use its results as a point estimate, and then we're going to infer this thing from the point estimate about the population, because chapter 8 says we can, because the 3 conditions are met: random, independent, and normal.
So remember, there is a difference between a population and a proportion. I think maybe they were hearing that P and thinking population. Maybe.
Yes, good point. Population parameter, there are, just as a reminder, there are 2 parameters we work with in this class: a proportion and a mean, and they're labeled that way. And their sample values, which we call the statistics, are the p hat and the x bar. So these are their equivalent things. So be careful, because this is a population value, p, but so is mu. It's a population value. So population is just like the all, whereas proportion is a percentage of the population, if we're talking about a parameter, or a percentage of the sample if we're talking about a statistic. Okay, did y'all get the critical value for B4B? Did you get plus or minus 1.96? One of the things you might start to notice is when we are calculating critical values, we often use the same confidence levels. Now, here's another weird thing about language. So we're going to construct a confidence interval, right? When we say 95, construct a 95% confidence interval, this 95 is understood to be the confidence level of the confidence interval, right? So it's rare that we say, here's the confidence level. We want a 96% confidence level when you construct this confidence interval. There's too many confidences, right? So we just put the percentage in front of the confidence interval thing. So get comfortable with that.
So the percents like that are always just going to be, you turn it to a decimal and put it as like what it equals for the normal calculator. Okay. That's what we
Yes.
can expect, like all the percents to be.
Yes.
Okay.
And 95 gets reused so often that you might start to memorize it's 1.96,
Right.
because that doesn't change. The other one is 99% is not too uncommon. And we have that up here, that 2.5 something. Okay, Standard error. How do we calculate the standard error? Well, let's go back to chapter 8, because that was a fun chapter. And when we calculated standard error, it was a part of the spread from the distribution of the sample proportions. And we calculated it this way. It's the square root of p hat times q hat divided by n. Now, I know in your notes, I believe you got another way to calculate the standard error, maybe not, from the confidence interval. No, I don't think you want to do it that way. So to get the standard error here, we're going to estimate it. Yeah, Brianna, I hear you. This class is all words. You've got to know the vocabulary. We hand you all of it, all the formulas, all the stuff. You just need to know where to put it all together. And the nice thing is we give you the reference sheet that has all the words on it. You just need to practice. And with a little practice, you'll get there. C level, critical Z value. Oh, I know, it's like tons of stuff. Okay, so the standard error, you just need to recall that that is the standard deviation of the p hat, which is approximately equal to the square root of p hat times q hat divided by n, the angry face. I mean, they used to do this without notes and you had to memorize everything. You know, before internet, that was actually a useful thing because finding the information took a ton of time. So having it all memorized. I mean, it used to be the only way you could do calculations was looking at a table like this. Because some guy got his master's degree in calculations, or some gal. Did you all see Hidden Figures? Right? The women there were human calculators, is literally what they were, because you didn't have things that could calculate, machines. We now have that, so that's not a useful skill anymore.
I did not show them this table, Eric.
Yeah, we don't need to see it. I guess we could look at it. I think it's, I don't know, I prefer this StatCrunch. Okay, so do we know p hat? Does anyone know that answer?
That's the answer to part A.
1,4.
Is that what it is?
No,
0.14?
no, don't, that was, I messed that up. You have to divide that. I think it's 0.59.
Does that seem good for you all?
So Reagan, I took 0.14 from question number 3.
Right.
Oh, we have to use question 4. Got
Yeah,
it.
we have to use question 4. Dang,
It is a p hat. They're both
we
p hat.
always have questions that have like multiple answers. Number 3 is one question. I'm like, no.
How could that be? Does anyone remember how to calculate q hat? And maybe a better question is, love it. Okay, Laura, I like that. Does it say 4 decimals somewhere? So I guess we should go ahead and in our calculation use 4 decimals. I'll show you what you could do is actually use the fraction and not do any rounding till the very end, but this is okay too. Yeah, so it's 1 minus p. The other thing I was going to say is maybe the better question is, do you know where to find what q hat is equal to in your reference sheet? And it's in chapter 8 right here, which is back from chapter 6. Okay, so what is this point? Oh boy, can I do this? 0.6099. And then that's going to be divided by our n, which is the 344. And this paper is getting super messy.
Yeah, Laura's right. It's 0.4099.
Yeah, that would make sense. Thanks, Laura. Now, I'm going to show you what kind of happens with rounding. So in Desmos, I'm going to type in the actual fraction, and we'll see how different are our results, because I'm assuming you all are typing in the 0.5901. So I'm going to do 203 divided by 344, and then 1 minus that. And then all of that Ooh, is that a fail? Nope, we're still good. All that divided by 344. So I'm getting 0.0282, yeah, 1, 2, 3, 4, because here's where we actually need to round.
Question.
Go.
I had a really hard time with Desmos. I think it's easier to use it than my phone sometimes. I know I got my answer right on my test, but that's because I literally did one step at a time, found the answer, then put the answer in to do the next part. I was having a difficult time getting the square root around the whole problem.
So let me show you a nice fix for that. In the table, you can hit the square root button, and inside there, if you hit the division button, it creates a fraction where everything's within the square root.
Oh, okay.
So Laura, you're not alone with that. In my in-person class, they were struggling with the same thing.
Okay. Thank you.
You are welcome. So notice there is a significant difference between using non-rounded values that I did here and rounded values, like 0.0265 versus 0.0282.
Show your
They
work,
would
you get it
both-
right. Show your work, you get it right.
There you
Right.
go. Show your work and you get it right. And like if I rounded to 2 decimals, it's 0.0261 or 0.0262. So as long as you write this down, as long as I see what you typed in your calculator, you're good. You'll be fine. That's probably dissatisfying, right? You're like, come on, we want the same answer. Yeah. Okay, how about the margin of error? Are there questions on that, or are we good? Anyone remember how to compute the margin of error? How'd you get that, Emily? I guess I should check the answer. I don't even know what the answer is. Oh, well, that's the problem. No wonder there's such different answers, because I can't type in the correct value up there. There we go. So my 2.82, thank you, Nikki, is totally wrong because I had the wrong number here. I had 230 over 344 as opposed to 203. So now it looks a little better. It's the same answer as rounded to 4 decimals. I should have known that. Shame on me. Because usually when you use 4 or more decimals, you'll be really, really close. So it's only if we did less than 4 decimals that we get a slightly different answer, which is this 2.62. Whew, that feels a little better. Did you all see what Emily wrote in the chat? The margin of error is the critical value times the standard error. So it's the 1.96 from question B times the 0.0265 from question C, which is, I'm assuming, the 0.0519. How we doing?
It's the critical value times the standard error. Is that what you said?
That's it.
Okay.
So it might be nice to, like, if that's what this says right here, that's what this is saying, but you have to recognize all these symbols. So you could write in your own personal thing, critical value. I don't know why I said values. Critical value times the standard error. That's one way to get it. The other way was upper limit minus lower limit divided by 2. Another way to get it is if you know the p hat and the sea level, then you just smash it into the calculator and it spits out the whole confidence interval and then calculate it from there. But yeah. Okay. Do you all know how to calculate the confidence interval when you know the margin of error and the point estimate? Trick question, because I told it to you up here and you did it here. We just took a little longer to get to be able to do that because we had to do these other calculations. So note that we know this margin of error. We just calculated it and we know this point estimate. Point estimate, let's call that PE. Margin of error, that's right here. And the confidence interval is the point estimate plus or minus the margin of error. That's one way to build it. We tend to write it like this with numbers in there. So what is it? Or should I give you some time to try to figure it out? Let me give you 5 minutes to work on these 3 questions. Because I'm like bombarding you with questions and not giving you any time to think. Set a timer for 5 minutes. How we doing, y'all?
I'm ready.
Okay. So how did we get the, how did we get this confidence interval? What'd y'all have?
I had 0.590 minus 0.0519 for one of them,
Nice,
and then added the 2 for the next one.
nice. So whether we use 4 decimal places or 2 decimal places doesn't particularly matter. That's great. That's perfect. That's exactly what you're going to do. So your lower limit of the confidence interval is the one you subtracted. The upper limit of the confidence interval would be the one you added. Whatever those numbers are your answers. I'm just using 4 because it said to round to 4 decimal places in the above. So I'm getting 0.642 as the upper limit. Come on now. And and 0.5382 is the lower limit. Now, if you wrote these in percentages, that's fine too. That might actually help the last question. That's up to you. So it could also be this. So do you have the interpretation in your reference sheet yet? Isn't there a sentence structure here that we can use? Right here. This is your sentence structure. This is page 209. We are blank confident that the true population parameter is between blank and blank. And we're going to state what this is. Is there another place where we write it a little more explicitly or no?
That is the only place. Did you want any context in there, or do you want just like proportion or mean is that?
So we'll toss in the context. Basically, you just say what it is. And a survey said that playing soft music leads to better studying. There it is. So we would say, oh, I can type it. Yay. Here we go.
Yes, in context.
Right. We are, was this 95? I think it was, right? We are 95% confident. So there's a confidence level that, if I could spell it right, that the true parameter, so that the true, how do we want to say this?
So how we started all these out, Eric, is we said we are 95, my dog, sorry, 95% confident that the true population, and then we said, yes, of all.
Okay, love it.
And then it's like this one would be,
who think that
yeah,
playing soft music leads to better studying. That's kind of annoying. Is between 53.82% and 64.2. Boy, 64.2%. Yes. You don't have to get that crazy, y'all, and when you do it. But that's the idea. I do want to see that you know what it is we're talking about in the problem. And in this case, it's playing soft music while studying, whatever that means. You can also substitute the between statement with the words is within, and then write the interval. I'm happy with that one too. Either way. Okay, so then the crazy question. What did you all say for G? So a reporter later claims that less than 62% of high school students. So we need to pay close attention to these words and the number. So let me show you the different options of what is going to happen here. When we're testing a claim, we've got this confidence interval, right? Come on now. So this is the confidence interval with its upper and lower limits. You know what? I better put them in there. So we've got a lower limit and we've got an upper limit. So what happens is there's three places the claim could be. The claim could be here, the claim could be here, or the claim could be here. In other words, we're saying the claim could be below the lower limit, within the limits, or between the limits, either way, or above the limits, right? That's where the number could be in our claim. So then if we claim that, so if the claim is the true proportion is above a number and the number is below the lower limit, the claim is true. So if we claim above and the number is below, it's true. If we claim equal to and the number is within, we claim true. If we claim less than and the number is above the upper limit, then it's true. Y'all with me on that? Which is weird, right? It's opposite the claim. So when we look at this, our person claimed, our news person claimed that it's less than 62%. So where is 62% relative to the confidence interval? I'll write it here and let's just state, is it below the confidence interval, above the confidence interval, or within the confidence interval?
Within.
Good, good. 62% is somewhere in here-ish, right? So if we had claimed that the true proportion is equal to 62%, our confidence interval supports it, right? Because that's within the interval, and that's what an interval says. The true parameter is somewhere within these numbers. We don't know exactly, but we know it's within here, and we know that with 95% confidence. Okay, so he claimed less than. He or she claimed less than, whoever this reporter is, the reporter claimed less than. Does our interval support that it's less than 62%?
Yes, because it goes down to 53.82, which is less than 62.
I like that, but the interval says the true proportion could also be all the way up to 64. So it's somewhere in between here. So it could actually be greater than 62%. Does that make sense? Like, it doesn't support it. It contradicts because 62% is within. And the reason it's contradicting is because our claim is that it's less than.
So you have to think about the entire interval, not just one of the numbers.
Right.
So think about both of the numbers. The entire interval is not below 53.82%. Part of your interval is, below 62%. You have a little bit above. Your upper limit is above.
In fact, that's what when we claim when you make a less than claim, all you care about is the upper limit. Is your number above the upper limit? Which is
So
what I was,
then-
go ahead.
sorry. So then to support, if it was to support that, what would the question or statement say? For it to actually be, it would have to say a reporter later claims that it's equal to 62%?
Yep.
Okay.
And we get this percentage for an equal to claim that is supported by the interval. It could be any number between these two numbers. So we could say 63, we could say 55, any value that's within the interval and we claim it's equal to, it's supported. If we had said a reporter claims that it's greater than 62%, that one isn't supported either. It's contradicted because to prove greater than, the number would have to be below the lower limit. It'd have to be somewhere down here, like 50%. If the reporter claimed that more than 50% of high school students think playing soft music leads to better studying, it would be a support because it's below the lower limit. It's a tricky question because there's 6 possibilities, right? Our number could be below, within, and above, and our claim could be above, equal to, or less than. Okay. Nice. We got the worksheet for 033 done. Now, let's see how well you know this with the 133 worksheet. So this first one, question number 1, I'm going to give you 5 minutes to work on it. Note you are finding critical Z values. And then this one, you're finding the confidence level. So my hint is you're going to do most of this stuff in StatCrunch except for D. You don't need StatCrunch. You just need that the C level is equal to 1 minus alpha. No worries. How much do you need, Taylor? Is this enough? Awesome. Okay, y'all, try number 1. Set a timer for 5 minutes. Okay. How many critical Z values for a confidence interval for a population proportion? 1, 2, or 0? Yeah. How do we know? Look at 272. Is that the right one? Yeah. Look at right here. Plus or minus Z alpha divided by 2. That's the critical Z value. Plus is 1, minus is the other. Confidence intervals always have 2 because we're using them to calculate the lower limit and the upper limit. That's why we're adding and subtracting. This looks, I think this can be misleading for students. It's a very algebraic way of writing things. We could really write this as two numbers. Okay, excellent. What'd you get for B?
The second one.
Nice. 1.4395 plus or minus. Good. Ooh, what'd you get for the confidence level for C?
I thought it was the third one, but I'm not totally positive.
So as long as you did this and you got 0.86 as your confidence level, nice, Misty. And then you smash that into StatCrunch and you got 1.4758 plus or minus. There it is. It's number 1. If you
I
put
see
in
what I did there.
0.14, you would have gotten the 0.764 thing, right?
That's what I did for D. And then I was looking for 86%. Is that right?
You did 1 minus 0.14 for D?
Right.
Yes.
Okay.
Yes. And then you should be typing in. So we have the wrong answer here if you took alpha and used that as your confidence level. And if you think about what the confidence level means, like how useful are your results? We're 14% confidence, our sample size has the true proportion, right? Like that's not even worth our time. Even 86 is pretty low, right? That's pretty bad. 14% chance that the sample doesn't contain the true proportion. Like that's not great. Pretty standard is 95% confidence level. Sometimes we dip as low as 90%, but rarely do we go any lower than that. Cool. Did anyone do number 2? You know what? Let's do 3 minutes on the clock for 2 and 3A. Set a timer for 3 minutes. They're the same questions we did on the previous worksheet. So refer back to those if you need to. Okay. How do we do? Well, first, let me ask you all a question. What's this 60%? Confidence level, p hat, t, mean, standard deviation. Yeah. How did we know? What is the clue that that's a p hat? Oh, it's a controversial issue, isn't it? I didn't even read what the question was about. How do we know? Go ahead.
Is it because of the margin of error?
Actually, when I read this, it's because it says a recent survey. So that means it's a sample. Otherwise, you know how we talked about this, of adult Americans believe there's an implied all, 60% of all. So the thing that takes away that implication is the fact that it came from a recent survey, which meant it's a sample value. Because if we said something like prior knowledge, I don't know. Yeah, this is a tricky one because most often we consider this to be a P based on the language. Because usually when we talk about a p hat, we give you the size of the sample somewhere in the problem. Okay, but Reagan, I guess that is another good point. If we give you a margin of error, then the percentage we gave you is going to be the p hat when we're talking about proportion. Okay, so then we got margin of error is at 3%, which we're going to add and subtract that. What do we want? 63.1% is the upper limit, and 56.9% is the lower limit. So I suppose, like, if we were talking about Michigan, I believe this is what Proposition 3 is about. Codifying abortion. If this were the results for Michigan, I think it would pass based on this sample, because isn't it, what is it that it has to be for a one of those things on the ballot? Is it above 50% or is it 2/3? I don't know. Okay, what'd y'all get for the point estimate in number 3?
I'm not sure what to do here at all.
What's a point estimate? Maybe we should start there. What does that mean?
X over N. That's what I did.
So I don't want to mess you all up, but that's only true for today, because tomorrow a point estimate is going to be X bar. So when you go through 9.2, you may have to calculate it from a list of numbers that we provide you in StatCrunch, or we may say the sample mean is this. So point estimate is the general term for a statistic. And the statistic we're working with depends on what are we talking about in the problem. And in this case, we told you proportion. And so we know the calculation of the statistic for a proportion. In other words, the sample proportion is done by this little formula, X over N. So N is the number of people we talk to. X is the characteristic of interest, or the success rate. And then I think Misty's got the answer there in the chat. It's the 0.549. How do y'all feel about that?
It's just all the words. The words are really getting me.
So a nice glossary might help. Does it say in here? Does it say point estimate? Oh, it does say point estimate right here on the reference sheet. So the words are here. But I agree with you, Laura. That is isn't that everything in life? It's always the words. It's always the words. Okay, now we're told to construct a 90% confidence interval. So we could do it how we did here, where we could go find the critical value. We could calculate the standard error here, and then we could calculate the margin of error from those two, and then we could add and subtract and get our confidence interval. But it turns out there's a much faster way to do this in StatCrunch, which I know you saw in the notes, but you may or may not remember that. So let me just remind you. You're going to go to Stat, Proportion Stats, and One Sample. Now, we will never have a data set for proportions. We're always going to use summary stats. And that's because the data sets are kind of annoying. They're going to be like yes or no. So we always just give you the summary. And notice what you need. You need the number of successes, and you need the number of observations. So recall that X is the number of successes, and N is the sample size, which in this case is the number of observations. That's all we need, that in the confidence level. Those are the three things we need to let StatCrunch calculate the confidence interval for us. So we already identified them back here. The X is the, what is this? Where is it? 558. The N is the 1015. And the C level is this. And again, notice it says 90% confidence interval as opposed to C level. So we're going to type that in. 558. 1015, and then notice it says perform. Perform what? Well, we're constructing a confidence interval for a population proportion P, and it just says level here, but it means confidence level, and we want that to be 90. And always leave this standard walled. I think there was once a question in StatCrunch that did a Grusty, I don't even know how to pronounce that, but we're not going to do that. Because it says include formula, substitution, and results, we want to know what the critical value is, because that's part of the formula and part of the substitution. So click that for your output. And we really don't need anything else, although we could check out the confidence interval plot, but I don't know that that's that useful. Click compute, and here's everything we need. So here's the X, the N we told them. Here's the P hat, 0.5497539. So I guess if we're rounding to 2 decimal places, really we should go back here and make a quick change. This should be 55. Even if we were rounding to 3 decimal places, it would be 55, because that 7 makes the 9 larger. And then here's the standard error that we don't really need to write down. Here's the critical Z value we need to write down. And here's the lower limit and the upper limit as decimals that we're going to write as our answer. So let me clean up what's going on here. And we'll write this how we kind of want you to do this. This is, so what we want, oh, come on. What we want to see is that you know the formula. And the formula is right here. Part of the reason I'm going to ask you to do this, here's the formula, shoot, is because there's a bunch of different formulas, and if you can identify the correct formula, then you're in the right spot. I mean, I don't know. Some people can argue that that's worthless. Sometimes I agree. So here's the formula, P hat plus or minus the critical Z value times the standard error. So P hat, Q hat, all over N. That's the formula. The substitution part is then the answers, the numbers for each of these things in here. Now, really, if you look at what StatCrunch needed, we needed the X and the N, and then Oh, that was it. So I don't know. Let's write out the things that the formula needs. So p hat z alpha divided by 2. I'm getting that from right here, 1.645 plus or minus q hat 0.45 in 1015. That's the substitution part. So here's the formula, here's the substitution, and then the results is this given to 4 decimal places. 0.5241, comma, 0.5754. Now, if you want, you can write that as you can write those as percentages if you prefer. So that would be 52.41%, comma, 57.54%. How you all feeling about that?
What is the thing in front of the 0.45?
That's isn't it clearly a Q hat? Yeah, sorry.
Oh, okay.
Bad handwriting. Maybe that's a little better. It's the part of it's the right eye of the angry face. So I should have labeled these a little better. This is the substitution part here. This was the formula part here. This is the result part. You only need one of these 2 result parts, either this one or this one. Anyone interpret these numbers in context of the situation? Or do you need time to interpret it?
We are 95% confident that that they think that the true population proportion of all adult Americans that think parents do too much for their young children is between 52.41% and 57.54%.
Love it. Boy, if I had a nickel for every time I heard this from my grandma. Back when I had kids, they slept in the dresser. Okay, grandma. I bought my kids a bed. I probably do too much for my kids. It's probably true. But boy, my grandma loves to loves to tell me stories. And some of them are quite awful. She's like, with one of her kids, she said, I woke up after giving birth totally naked in a cold room in a pile of blood all by myself. And the baby was like gone. She was just like laying in this room. I'm like, oh, well, that sounds rough. Sorry. That sounds really callous, doesn't it?
Can you show me the StatCrunch steps again slower?
Yeah, most definitely. Yes. So you go to stat, proportion stats, and one sample. Then with summary. And before I click further on that, let me go over here and show you how we list it out for you here as well. This tells you here's where to go in StatCrunch in case you were to forget this down the road. It's right there saved for you. So there. And then when you open that up, there's only 3 things we have to enter for chapter 9. Number of successes, which is X. And that was the 558. Number of observations, which is N. And this might be something you want to write down on your reference sheet. Like the reference sheet just says, here's where you get the calculator, but it doesn't remind you that what you're typing into StatCrunch is that X and that N. And identifying X as number of successes and N as number of observations. I've seen students like forget that. Like, what is observations? What is successes? I've also seen students flip these, which will give you an error. So make that a note somewhere.
Write it right there where Eric did.
Yeah, right there on the sheet that you're going to bring to the final exam. Okay, and then the other thing we have to do, there's two things we can do. Chapter 10 is hypothesis testing, so that's coming. For now, chapter 9 is we're doing the confidence interval. How did we know? It said it right here, construct a 90% confidence interval. So we just have to match confidence interval with the words confidence interval. And then the level is the percent here. So that needs to be the 0.90 for this particular problem. Often it is 95. You leave this alone, and then I clicked show critical value so that I didn't have to go anywhere to calculate this thing for the substitution. It was just, it showed up in the output. Is that good? Did I do it a little slower this time? I tried.
Yes, it made a lot more sense.
Okay,
Thank you.
good. Compute, and there it is. And you get a bunch of extra stuff in here, right? The only things we really need are these last three things. These are the three things we're going to write down. The other bits we already have. The p hat and q hat come from the problem. Although if you hadn't calculated p hat yet, it's right there. Okay, I'm going to skip this question because this is a can you read the output and put the stuff together question. And I'm going to go to this question, which does everything from start to finish. It goes back to chapter 8 and says, can you verify the conditions? And then it gives you this little question, which is tricky. And then you are to construct the interval with the formula substitution result, like what we just did here. And then you interpret it like what we just wrote, and then you check a claim. So let's do 5 minutes and see how far you get. If you're wondering where the conditions are, they're right here. And if you're like, wait, those look super familiar with less words, you're right. They're the exact same conditions we did here. So if you're forgetting how to identify random, independent, and normal, and you need a little more language with it, there it is on your reference sheet from what we did in chapter 8. This is exactly what's happening here. We're confirming that the theory works, or that the theory was useful if these three things are met. So you'll answer this question the same way you did back in chapter 8. Okay, seriously, 5 minutes. Here we go. Set a timer for 5 minutes.
Eric, while they're doing that, can I ask you a quick question?
Yes.
So for tomorrow, when I do the means, when we do the T-stat, so I'm like on page 216. So when I run a T-stat for that, when they do the substitution part of this, some of my instructors allow them, so the formula is, X bar plus or minus your critical T value times supposed to be standard deviation divided by the square root of n. Can you use the standard error of X bar instead of the standard deviation? Because otherwise you have to run a summary stat on that to get your standard deviation. But if you run a T-stat, it gives you the standard error already. So you don't have to run a summary stat. You can just grab your standard error and you can just do it in one set.
Let me see. I think there's a button you can click that gives you the standard deviation, just like that Z-score, but I could be wrong.
You might be right.
Let me just double check.
Jamie and Matt both had me just change the formula. They changed the formula to the standard error of X bar, which, I mean, obviously you get the same answer.
Right. which is fine. I'm okay with that. So I guess there isn't a way. Usually I thought there was a Q main marker kind of a plot. I guess not.
So yeah, I think I mean, obviously it's just for the substitution.
Right.
So given
Right.
that standard error,
Right. Yeah,
which
that's fine with me.
I mean, if anything, it's going to be some kind of rounding
Yes.
issue that you might have that's a little bit off. So it's totally up to you, because it's not hard to do a summary stat on that to show the actual substitution. I just want to do whatever.
Everyone put your earmuffs on. I don't even like all that. Part of me is just like, let's just do this. If you can get to here, great. Like, we don't need all the other stuff written down.
Yeah.
You know what I mean? Like,
I
it's
just,
a waste of time. In my opinion, it's kind of a waste of time.
yeah, I totally agree. I don't like having to show formula substitution. Let's get us,
Fine.
but I'm doing what it says to do. So
Yeah, that's totally fine. Do the like,
just do the standard error.
yeah,
Okay. Got it.
this one, right? This is the one.
Yes.
So you write this, because then everything, you're just copying down everything from here. We've got the critical T value and the standard error
Yes.
and the X bar. Yeah.
Got it.
I like
Yep.
that.
All right. Perfect. But I'm all with you. Let's just write down our
Just write down the
lower limit,
content.
upper limit. We're good.
I mean, in chapter 11, we do that, right? 'Cause now it's
Exactly.
super
Exactly.
long.
Well, I'll tell you that, I don't know how Matt wants them to put that in a calculator. Every single one he showed putting in it, he did it out with a plus sign and a minus sign. And I'm like,
I mean,
there is StatCrunch that can do it for you.
I mean, I get like the plus or minus can be confusing for students because it looks like it's one thing, but it's really two, but I don't know. Yeah.
No, I didn't say that.
Yeah. To each their own. Okay, y'all, we're not going to have a whole lot of time to go through this. So let's start with B. Did anyone understand what B was asking you to do?
I just did 62% of the 1,895.
Excellent. We're trying to figure out what X is. So if you want a little formula, and the reason, of course, is because in StatCrunch, we have to put X in there to get the confidence interval. So if you want a little formula, because like, I don't know, it's that. X is P hat times N. Now you have to round this to the nearest whole number. Because you can't have part of a person, and StatCrunch recognizes that. So this is 1175. And we know that's going to be the exact value because that 62% is rounded. So if I take 1175 and I divided it by 1895, you can see that it was 62.000527777. So they rounded to 62, and all of this is equal to one person. Okay, so we needed that then to smash into here all the stuff. 1175, this 99 0.95%. Here is the results. I'm just going to write it up here so you have it, so you can come back and check if you didn't have time to do this, because we're about out of time here. 5 decimal places. Lovely. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. That's the result. Your job is to go back and write up the formula and the substitutions. So here's the critical value associated with 0.995 and all the rest. So I've left you with this question to work on, which is reading the output. Notice we kind of purposefully left some numbers out. We left out what X is, and we left out what P hat is, but we didn't really leave it out because you know this. And so you know N. Oh, you're gonna have to use the stuff, Reagan, you talked about. P hat is the center. It's the center of the upper limits. So it's the lower limit plus, it's the upper limit plus the lower limit divided by 2. That's another calculation for P hat. Okay, so I'm happy to take questions off of this on Wednesday if you get stuck on these, but I would really like you to try them. See how far you get. You still have a little bit of things left to do here. The questions mirror what we did back here. Tomorrow you're doing 9.2, and then Monday of next week, I think it's 9.4, and then we'll be done with chapter 9. And we'll be going on Thanksgiving break the 23rd. So yes, and I think I should be able to be in class. We'll see. I'm going to Toronto on Wednesday, but I think I'll be I might be able to zoom in from the car. We'll see how that goes. Okay, so great work, you all. Keep trucking. It's getting exciting now. If you miss a class, if you miss Cindy's class, make sure you get the notes. I think that's going to be most useful for when you come into this class. So like if you come to this class and you're like, man, I haven't watched the videos, turn on the videos and take the notes and ignore me. Because what we're doing here is practicing what you saw in the notes. I mean, if you get something from what we're doing here, great. If you're just getting the answers to fill out the worksheets, bad. Don't do that. That's a waste of your time.